In this video, we are going to find trigonometric ratios beyond triangles. So far, we have been using triangles to find the sine, cos and tan of different angles, which means we were restricted to 180 degrees. After viewing this video, you will be able to find the sine, cos and tan on other trigonometric ratios even above 180 degrees. For this, we need a circle. This circle is a unit circle because the radius is taken as 1 unit. And we consider a particle moving around a circle like this. If it rotates a complete circle, then it sweeps an angle of 360 degrees. This is the concept we are going to use in order to find the trigonometric ratios of all angles from 0 to 360 and more. Let's consider this circle. This smaller circle here is a unit circle because the radius of this circle is 1 unit. Let's consider a point P on the circle. Say this is point P, and let's say that its coordinates are x, which means that this is y and this is x. Obviously this is 1 because this is a unit circle and this is the radius of the circle. If this is the angle theta, then considering this right angle triangle, sine theta is y over 1. Therefore, y, which is y over 1, is sine theta. And cos theta is x over 1. Therefore, x can be written as cos theta. Therefore, the point P can now be written as cos theta, sine theta as its coordinates, where theta is the angle made by the point with the positive x-axis. Let's see how the point moves around the circle and how we can make different angles for the trigonometric ratios. As the point moves, this is the angle made by the point with the positive x-axis and vertex as the origin. Now the point is here, therefore this is the angle swept. And the point moves further, which is now in the second quadrant. In a graph, we say this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant. Now the point is in the third quadrant and the angle swept here is here. As you can see, the angle is always measured from the positive x-axis and towards the point. Now the point has completed one full rotation, that means it has completed 360 degrees. When it was in the beginning, it was cos 0 and sine 0. And here the angle is 45 degrees. Now it is 90 degrees, therefore it is cos 90, sine 90. Now the angle is 135, so it is cos 135, sine 135. Here it is 180, here it is 225, this is 270, 315, and this is 360 again when it comes back to its original position. Hence, what we have seen is any point on a unit circle with origin as center will have its coordinates as cos theta, sine theta, where theta is the angle swept by the point from the positive x-axis with the origin as its vertex. This is a summation of what we have done just now. This concept is useful in making the graph of sine and cos. In order to find the graph of sine, we are using a unit circle here where the point starts moving from this point towards 360 degrees. This is a small graph which is going to be helpful to make the sine curve. This line has angles on it 0, 90, 180, 270 and 360. Therefore this can be considered as your x-axis. On your y-axis you have 0, positive 1 and negative 1. So as the point moves, you are going to see how the values of sine can be plotted on this graph. Now the point is here, which means that it is at 0 degrees. At 0, the y value is 0. Remember, the y coordinate of the point P was sine theta. Therefore, theta is 0. Therefore, the y value is 0. Now the y value starts increasing as the angle moves on. So as the angle moves on, you can see the y value goes on and on up to positive 1. Now the angle swept is 90 degrees here and the value of y is positive 1. As you can see that the y value is positive 1 here. Therefore the sine curve reaches here when the angle is 90 degrees. As the point moves further from 90 degrees to 180 degrees, you can see that the y value gets reduced. and becomes 0 at 180 degrees. This is 180 degrees and it's 0, and the y value goes on increasing to -1 at 270 degrees. This is -1. As the point moves towards the 360 degrees, you will notice that the y values gets reduced and becomes 0 at 360 degrees. Therefore, this is a typical sine curve. 0, 1, 0 here, -1 and 0 at 360 when the particle makes one full complete rotation. Let's see how cos values are plotted. For cos values, we are making shifting the graph vertically. The angles are formed along this line 0, 90, 180, 270 and 360, and the values of cos are plotted along this line. So the values of cos can go from 0 to 1 or 0 to -1. As you know that x value of this graph gives you the cos value of the angle. Therefore, at this point the angle is 0 degrees and the x is 1. Therefore, at this point, when the angle is 0 degrees, the value of cos is 1. Therefore, the cos curve starts here. As it moves on further, you can see that the x values gets reduced and goes to 0 at 90 degrees. From 90 degrees to 180 degree, the cos goes this way, and I can see that it increases but goes to -1. And then it decreases to 0 at 270 and goes on to +1 at 360. Therefore, this is a typical cos curve. Let's see how a sine curve behaves. This is a typical sine curve. It starts from 0 and goes on up to 360 in this way. The x-axis has angles and the y-axis has +1 to -1. As you can see, the curve goes from 0 at 0 and 0 at 360. Now, when the point moves from 0 to 360, you have one single curve of sine. The particle can move further again and again around the circle, and you will have more such sine curves. The second curve is from 360 to 720, where the particle has made another rotation. If it makes third rotation, you will have the third sine curve, and so on. You can also have negative angles in the sine graph, which means that the particle is moving along the circle in the clockwise direction. If it moves in the anti-clockwise direction, the angles are taken positive. It moves in the clockwise direction, the angles are taken negative. Therefore, the negative x values corresponds to the clockwise movement of the particle. Now, this blue curve is the cos curve, which is easily seen. The cos curve starts from 1 and goes to 1 again at 360 degrees. At 0, the value is 1. 180 it is 0. 90 it is 0. 180 it is -1. It is 0 again at 270 and +1 at 360. If the particle rotates again on the same circle from 360 to 720, you will get another cos curve, and so on. The curves sine and cos repeats itself again and again within a specific set of angles. So it repeats from 0 to 360 in the same way as from 360 to 720 and so on. Therefore, these sine and cos curve are known as periodic functions. Let's combine this concept with the circle concept which we just saw. First, let's deal with the sine curve. The sine curve looks like this from 0 to 360. You should have noticed that I have used the angles in radians: 0, pi over 2, pi, 3 pi over 2 and 2 pi. When a point starts moving along this curve from 0 to 90 degrees, you can see that the curve is on the positive y value. That means if the particle was here, the value of sine is 0. When the particle gets to here, the value of sine is 1. That means from here to here, the sine value was positive. From 90 degrees, which is pi over 2, to pi, the value of sine will still be positive, but it is reducing. So, from pi over 2 to pi, which is in the second quadrant, the value of sine is positive. From here to here, it is still positive. This is 180 degrees for those who don't know what is a radian. The particle, if it continues moving from 180 to 360, which is 2 pi, you can see that the sine function is below the x-axis, which means that the sine values are negative. So from 180 to 360, this is again 360. From 180 to 360, the sine value is negative. So from 0 to 180, the sine is positive. 180 to 360, the sine is negative. So how do we account for this? Let's take a circle on a graph sheet. You can see that this is the x-axis and this is the y-axis. As I have already mentioned, this is the first quadrant, this is the second quadrant, this is the third, and this is the fourth. The quadrants are measured from this part anti-clockwise. So the first quadrant, we saw that the sign is positive. The second quadrant, again the sign was positive. But in the third and fourth quadrants, the sign was negative. So this is how the sign values are in 4 quadrants. Let's move on to cos function. This is a typical cos function. Now the point starts from 1 at 0 degrees, and then it moves from 0 degrees to pi over 2. You can see that the cos value is on the positive side of the y-axis. From pi over 2 to 3 pi over 2, which is 90 degrees to 270 degrees, the cos values are negative. You can see that it is below the x-axis. From 3 pi over 2 to 2 pi, which is 270 to 360 degrees, the cos is again on the upper side of the x-axis. That means it's positive. Therefore, in the first quadrant, which is 0 to pi over 2, the cos is positive. The second quadrant, cos is negative. Third, it is negative again, but in the fourth, it is positive. So if we move back to the same circle and say how does it apply here, we saw that in the first quadrant cos was positive. In the second quadrant cos was negative. In the third quadrant also cos was negative, but in the fourth quadrant cos was positive. So it is cos is positive, negative, negative and positive as the point moves along the 4 quadrants. We also know that tan of any angle is sine theta over cos theta. So we can also find the values of tan along these 4 quadrants. Sine over cos, when both are positive, tan will be positive. When one is negative, tan will be negative. When both are negative, tan will be positive. And when one is negative, tan will be negative. So tan is positive, negative, positive, negative in the 4 quadrants as it goes in this way. Now we can find out which are positive in each quadrant. In this quadrant, all are positive. In this quadrant, it's only sine which is positive. In the third quadrant, it is only tan which is positive, which means the other 2 are negative. In this, the cos is positive. Therefore, if we draw a small graph here, then here the first quadrant all positive, second quadrant sine only positive, other 2 are negative. In the third quadrant only tan is positive and the other 2 are negative, and here it is only cos positive. So it goes like this, and we say that it is ASTC. You can remember it in so many ways. As you can say, all students take coffee. For example, you can remember it in any ways. It is ASTZ, first, second, third and fourth quadrants. So we should remember here that tan is positive in the first quadrant, tan is negative in the second quadrant, tan is positive in the third, and tan is negative in the fourth again. So we can easily plot the tan curve now. The tan curve looks like this. As you can see, at pi over 2, that is 90 degrees, there is the tan reaches infinity. Therefore, tan of pi over 2 is not defined. Whereas tan pi is 0, tan pi 3 pi over 2, which is 270 degrees, is again undefined because the tan reaches infinity here, and tan 2 pi is 0. 0 to pi over 2, 90 degrees is the first quadrant, and you can see that tan is positive. And tan is negative in the second quadrant. Tan is positive in the third quadrant and it is negative in the fourth quadrant, as we just saw. Again, tan can repeat itself after every 360 degrees as sine and cos did. Therefore, tan is also known as a periodic function.